the second transformation that we're looking at today, so first we did reflections, today we're looking at translations. Now remember from last time that a transformation where the pre-image and the image, so the original figure and the new figure, where they're congruent, that's called an isometry. Okay, so today a translation, and another word for translation is, so we'll do a little arrow here, is a slide. So you're just like sliding a puzzle piece, sliding a figure. A translation is an isometry, so the pre-image and image are the same, that maps all points of a figure the same distance in the same direction. And again, it's easier to think of it as just you're sliding a piece from here to here. It's not much more complicated than that. Now, we do use an old concept to kind of think of translations. So remember back in Unit 8, when we did like SOHCAHTOA, in that unit we talked about vectors, which kind of just looked like an arrow. And vectors have magnitude, which means like size or length. Vectors have magnitude and direction. So that's kind of exactly what's happening here with the translation. You move a point or move a figure a certain number of movements in some direction. Okay, so we're going to use vectors to describe our slides or our translations. Now, a big part of this is just understanding like the notation and what the problem is asking you to do. So realize that a vector is made of an ordered pair. And they're going to use those like less than and greater than signs for the instead of parentheses. So they do that around the ordered pair. And we'll just call the ordered pair like A, comma B. Now, the A is like acting like the X, and the A represents the horizontal change, either left or right. And then the B is like the Y, so that obviously represents the vertical change, either up or down. So they're going to give you a vector on these translation problems, and that's just explaining to you how you're going to move your figure or your point that you're translating. So the first number tells you left and right, the second number tells you up and down. Now we say that a vector, and again we'll call it like AB, a vector maps each point X and Y to a new point, and here's what that looks like. And it's kind of like the exact same thing that's down here, and really the only difference is like the arrowed, the pointed parentheses and then the actual parentheses. But really all they're trying to show you here with this like fancy notation is that you take the original X value of the ordered pair and you add on whatever the vector's X value is, and that's your new X value. You take the original Y value and you add on the vector's Y value, the B, and that's your image's Y value. So again, the notation is kind of like the hardest part here. It's not nearly as complicated as it seems right now. Let's say that they gave you the vector -3, 4. That's just them trying to tell you like where do you move the figure, where do you slide it to. All this means is that they're taking the X value and they're subtracting 3, they're taking the Y value and they're adding 4. So this means that each X value of the image, the new picture, is 3 less than the X value of the pre-image, and each Y value of the image is 4 more than each Y value of the pre-image. Again, that's like super wordy, but it's not nearly as complicated as it seems. So let me show you a few examples, and I think you'll pick this up pretty easily. It says use the rule x, y, so okay, we're adding 7 to the x and we're subtracting 1 from the y to find the translation image of this triangle right here. The first thing you'd want to do, guys, is plot the pre-image. So get these 3 ordered pairs on here. Okay, so there's W, make sure you label them. there's G, and N is right there. Okay, so this is the pre-image, the original triangle. Now let's try to make sense of what they're trying to show us here with this rule. And another way to write this is they could use a vector notation. You're adding 7 to the x, so they might just say 7, and then you're subtracting 1 from the y, -1. So they could write it either way, but all they're trying to tell you is how to move W, G, and N, how to move each ordered pair. If the x value is a positive 7, you're going to move in a positive direction by going right 7. And then the y value is a negative, so that's up and down, and since it's negative, I'm going to move down 1. So all I'm going to do is 1 point at a time. I'm going to move them right 7 and down 1 and plot the image on my x and y axis here. So let's move G first. Let's go right 7 and down 1, and that would be G prime. N, same thing. Right 7, down 1, and there's N prime. And then do the same thing with W. And that's W prime. Kind of missed a little bit, but that's all they did. They took this green triangle and they slid it over here, or they translated it, right 7, down 1. So really it's not that fancy. You're just moving ordered pairs. On the back, it's the same idea, but they want you to tell them how they translated it. So the hardest part, again, is like writing it correctly. But the first one, they want to know, how did they go from Z to U? So from Z to U. And you're going to write it as a vector to show movement. And you're just going to do like a fancy ordered pair with the little less than and greater than signs. I just got to count. How do I go from Z to U? So I went right, 1, 2, 3. So positive 3 for the x. And I went up 1. So 3, 1 would be the vector that describes that slide. From Y to W, so from here to here, you go right, 1, 2, 3, 4, and down 2. So since you went down, it's got to be a -2 for the Y value. From U to V, you go right 2, and down, right 1. Go right 1 and down 1, 2, 3, 4, 5. Make sure you make that a 1, not a 2. For number 4, to go from X to W, let's see, there's X right in the middle. So I don't want to go left or right, so it's 0, and then just down 1, 2, 3, 4, -4. Kind of getting redundant, hopefully you're getting the point. Then to go from V to Y, I want to go left, 1, 2, 3, 4, 5, 6, so -6, and I do not want to move up or down, 0. All right, number 6 says a point is mapped using the vector 2, -6, so that's telling you that they moved right 2 and down 6, and the image, so like where they landed, was at W here. I want to know what's the pre-image, or in other words, like where did we start? So I'm just going to do the opposite of this movement here, and that's where they would have began this process. So I know they moved right 2, so I'm going to count left 2. And I know they counted down 6, so let's go up 6. And let's see, let's make sure we did that right. Left 2. Yep. And the pre-image would have been point Z. That's where they started. And you could double check yourself. Let's see, if I go right 2 and down 6, yeah, I landed at W. All right, last example here, example 3. It says, find the image of the point under the translation given by each vector. So the pre-image is this point right here for all of them. And I'm just going to count all of these translations and mark the image. So to plot point A, I gotta do these moves here, which would be -1, 4. That's gonna be left 1 and up 4. Okay, so that's A. And it kind of looks like they want me to tell what the ordered pair is. So let's see, that'd be 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6. -5, 6. Let's see, now they want me to translate it 5, -3. So that'd be right 5 and down 3. That would be point B, which is the point 1, -1. Now they want me to not move left and right, just go up 2 from the pre-image point. And that would be point C, which would be, let's see, 1, 2, 3, 4. -4, 4. So you guys can see it's kind of the same thing over and over again, which is fun. Let's see, the last one, I want to go 10, 4. So right 10 and up 4. Which would be right there, point D, which is 6, 6. And then the very last question, it says write the vector, so use your brackets, your little pointed parentheses, that would map the given point to the origin. Okay, so here we are, I want to land at the origin. So I would need to go right, 1, 2, 3, 4, and down 2. And that's translations.